Greetings and salutations, Gen3 community. Welcome to the 5th installment of the Gen3 Webinar series hosted by the University of Chicago's Center for Translational Data Science. Today, we will be exploring and analyzing cancer cell line data in a Gen3 data commons. Chris Meyer will lead us on this journey. He is a scientific support analyst in the center who holds a PhD in ecology and evolution. And he's a pretty swell person from what I can tell. My name is Trevor, and I'm your host for today's webinar. All webinar participants are muted by default, so we won't hear you typing those copious notes or asking interesting questions to Chris. However, feel free to ask a question at any point during the presentation by clicking the Q&A button at the bottom of your screen and typing your question there. If you experience any technical difficulties, please send a message in the Zoom chat, which will be monitored by my colleague Piyush Pandey. Please note that today's webinar will be recorded and made available on our YouTube channel at a later date for your viewing pleasure. Now, let's hand it over to Chris.
Thank you, Trevor, and thank you, webinar participants. I will go ahead and get started with the presentation by sharing my screen. The topic of today's webinar is data exploration in Gen3. And today we'll be showcasing the Gen3 services by exploring the cancer cell line encyclopedia data in the DCF Sandbox Commons. An outline of the topics covered in today's webinar will include exploration of the CCLE project structured data via the project model viewer, the Data Explorer UI, the GraphiQL Open API endpoints. Then we'll move on to importing CCLE data into a Gen3 workspace, performing exploratory data analysis in JupyterHub, announcing future Gen3 developments, and then finally, we'll have a live Q&A session with Gen3's product manager. So first, let's take a look at the CCLE graph model, which gives an overview of the project's structured data. The graphical model of a project is based on the data model, which organizes terms in a data dictionary and defines how they relate to one another. The data dictionary defines how data sets are represented in the database and harmonizes term definitions from different data sources. Data harmonization is foundational to the data commons concept of sharing data for cross-project analyses. A project's graphical model displays interconnected nodes that contain structured data records, which are collections of properties and their values. A structured data record in a node stores data as key value pairs, which can be queried. In the example on the left, you can see one record in the summary drug response node, which is in JSON format. In the CCLE project, for example, there are 1,046 records in the sample node, which represent samples of individual cell lines. That can be seen in the example below, on the right, where you see the sample node and the number 1,046. Those samples are then linked to 11,456 drug response summary records that contain information about the cell line's response to certain drugs. Certain types of data are stored as files as opposed to structured data. Records in a data file node describes files' properties like file names, size, GUIDs, which are unique identifiers for pointing to the storage location of the file. An example of a data file record is on the lower left, and this is an example of the aligned reads nodes. On the right, we see a snapshot of two data file nodes in the CCLE project's graphical model. Here we see that there are 926 files in the submitted aligned reads node and 6 gene expression files that are linked to those aligned reads. Next, let's take a look at the data exploration tool, which is a graphical user interface for cohort selection. Structured data in a project can also be explored using the exploration graphical user interface. Data records are filtered based on the selection of subject properties. The records for a selected cohort can then be downloaded or exported to the workspace. Additionally, a file download manifest can be generated for downloading all files related to the selected cohort. Also notably, the facets available for filtering and summarizing data are configurable. In the example snapshot, the DCF CCLE project has been selected, and the bar charts are updated automatically, summarizing the number of cell lines of each tissue type in the project. Data files in a project can also be explored using the File tab of the Exploration GUI. Data file records are filtered based on properties like file type, format, and category. A file download manifest can be generated here as well for easily downloading the batch of files using the Gen3 client. Files can also be easily exported to the analysis workspace with the click of the Export to Workspace button. In the example snapshot shown, the DCF CCLE project is selected, which filters file records to show only the 2,941 files available in the project. The bar charts summarize the number of data files of each type, format, and category. Now that we've looked at the data exploration GUI, let's talk about using queries and command line tools for data exploration. The interactive graphical interface makes building database queries much easier. To access it, you click on Query in the top navigation bar. This page features built-in documentation and history, autocomplete for objects, fields, and arguments, the ability to pass variables, the ability to switch between Elasticsearch and Postgres databases. The example query on the right searches the summary drug response node for the compound name, its IC50, and the area under its activity curve. The query also requests the primary site in the subject node, which is the property that stores the tissue type of each cell line. In addition to the graphical interface, all structured data can be accessed by sending queries or POST requests to the following open API endpoints. The Postgres database, which the graphical model is based on, uses the Peregrine service, whereas the Elasticsearch database, which the Data Explorer user interface is based on, uses our Guppy service. It's worth noting that the Elasticsearch database is configured for performant exploration queries, thus it typically only has a subset of the structured data available in Postgres, which are the data for cohort selection. Queries can also be sent to the GraphiQL API endpoints from the command line. The example on the right is a snapshot of a terminal window that demonstrates a POST request to the Postgres endpoint in a Python shell. The example query is similar to the one we saw in Graphical, and it requests the compound name, IC50, and area under the activity curve for each compound tested on a particular cell line. Guppy queries can also be sent to the flat model endpoint to retrieve structured data from Elasticsearch. Guppy queries have the ability to return aggregations and statistics. This example demonstrates sending a POST request to the flat model or Elasticsearch endpoint in Python. The query requests the primary site data as an aggregation, which returns the counts of cell lines per primary site. It's worth noting that if we'd queried a numerical property like drug EC50, we could have requested summary statistics with the Guppy query. Instead of requesting specific data using queries, all structured data in a node can be exported using the Gen3 SDK, which is an open source suite of functions for interacting with Gen3 APIs via the command line. The Gen3 SDK is installed and imported into Python using the commands install Gen3 and then import Gen3. The code is also publicly available on GitHub. In this example below, all records in the CCLE project's summary drug response node are exported as a single TSV. Now, we'll take a look at the CCLE project in the Gen3 workspace. This will be a live demo in which data will be accessed, prepared, and summarized in a Python notebook, and then we'll briefly switch over to an R notebook for further visualization. Here we can see the landing page of the DCF sandbox. If we click on Workspace, we can go to the workspace. Here we have a persistent drive where users can create files and they persist after you terminate the workspace. Anything outside of the persistent drive does not get saved. So here's a Python notebook demo. First thing we'll do here is install and import the Gen3 Python SDK using the install and import commands. Next, we create instances of the SDK classes. First, we set the variable API to the URL of our data commons. Then, we set the creds variable to point to the location of the credentials JSON downloaded from our user profile page. If you're curious where that page is, you can click on Profile in the top navigation bar and then create an API key and download it. Then, once you're in the workspace, you can click Upload, navigate to the file on your local hard drive, and upload it to your workspace. Finally, we create two Gen3 SDK instances, auth, which handles our authentication, and sub, which interacts with the data query, export, and submission API endpoints. Now we'll use the Gen3 SDK to download the drug response summary data. The SDK has a function called export node that can be used to download all the structured data in a single node of a particular project. Here we ask for the CCLE drug response summary data as tab-separated values, save it as a file, and then read that file into Python as a pandas data frame. Now that the file is downloaded, we'll read it into pandas. You can see that this TSV has a header for every property in the summary drug response node. It has the link to its sample, maximum activity, the compound name, area under the activity curve, the IC50 and EC50, as well as a submitter ID, which is the name of the sample that you can see has the drug name in it and also the tissue type that was tested in it. So the next thing we'll do is extract the tissue name and the cell line name from that submitter ID. And we add those as columns to our data frame. Next, I'll download a class of Python functions from my personal public GitHub repository and load them into JupyterHub. First, I download a file that includes some plotting functions that I wrote for this demonstration, and I grab that file using wget. Then I run the file to read the class of functions into my Python environment, and finally, I create an instance of this so-called Gen3 expansion class that I created. Now that my plotting functions are ready to use, I define the properties from the data model that I'd like to plot. Here we'll plot the distribution of EC50 data for each tissue type using the seaborn and matplotlib packages in Python. The custom function plot numeric by category plots the distribution of a numerical property by each category of a categorical property. Here you can see I've defined numeric category as EC50 and the category property as tissue. Then I run my custom function. Here we can see that the legend has repeating colors because there are so many tissue types. So the next function I wrote plots only the top 10 categories with the highest mean numeric values. This indicates which tissue type is on average the most sensitive to each drug tested. Next, we plot the area under the activity curve for each compound and each tissue in separate plots. First, we define properties to plot as we did before. Then we run the function plot top 10 numeric property by category, which plots only the 10 category 2 values, compounds in this case, with the highest mean numeric property value, area under the activity curve in this case. So each plot is an individual tissue type, and then it plots different distributions for each compound tested in that tissue type. I could easily change act area here for area under the activity curve to, for example, EC50, and run that again, and now we're plotting EC50 in each tissue type. These plots revealed that the drugs paclitaxel and panobenostat are on average the most active of all drugs tested, regardless of tissue type. Next, we'll create and save summary tables of the data we just downloaded for use in the following R notebook demonstration. First, we'll calculate the number of tissue types and cell lines tested for each compound. Then we'll calculate the number of cell lines of each tissue type. Finally, the data tables are saved to CSV files and read into R. Now that we've saved our files, we'll take a look at our summary tables. The first one is the average drug response data by compound. So these are averages across each cell line for each compound. The second summary table is the average drug response data by tissue type instead of compound. And then finally, we'll create a table of the average drug response data by compound for each tissue. Now that our data has been exported and massaged into a format for easy plotting, an R notebook can be created to use the ggplot library for making some interesting plots. So here's our R notebook. You can see up here the R symbol. First, we'll read in the drug response summary data exported in our Python notebook into R. Next, we add the ggplot package to our R library and set some plotting options. Then we plot the number of cell lines and compounds tested in each tissue type. In this plot, we see that the number of cell lines per tissue type varies. However, roughly the same number of unique compounds was tested in each tissue type. So on the top are the cell lines tested, and on the bottom is the number of compounds tested. And on the x-axis, we have the tissue type. Finally, we read in the drug activity data to create a heat map of the average sensitivity of each tissue type to each compound. From this plot, we can see again that each tissue type is most sensitive to the drugs paclitaxel and panobenostat, which are down here at the bottom. They have the darkest colors, which indicate that their area under the activity curve is the highest, meaning that the tissues are the most sensitive to those compounds. The X indicates missing data. The lighter colors indicate close to zero activity. I'd like to thank Fan Wang, a senior bioinformatician at CEDIS, for helping create the plots in this notebook. Now we'll finish up the webinar with a look at some upcoming Gen3 developments and an interactive Q&A session with our product manager, Abby George. Some of the future Gen3 developments include that users will soon be able to run containerized pipelines using our workflow execution services. We'll be improving the ability to export clinical data to workspaces. Also, we're going to implement versioning of clinical data so that users have the ability to select different versions of harmonized clinical data. Finally, we'll be redesigning the data submission process to make it simpler and more intuitive. You can learn more about the Gen3 software stack for creating data commons through the following resources. Our open source code lives on GitHub. Documentation for users, developers, and operators is at gen3.org. You can chat with our development team and support team live in our Gen3 community on Slack. In order to join this Gen3 community on Slack, please contact us at the forum, where you'll also be able to ask questions and find answers to frequently asked questions. If you have any trouble, feel free to email our support team at support@datacommons.io. And to learn more about the Center for Translational Data Science, where Gen3 was created, visit ctds.uchicago.edu. Finally, you can view data statistics on several Gen3-powered data commons at stats.gen3.org. And below, you can see the logos of several of the data commons that we currently manage. Now we'll move to a live Q&A session with our product manager, Abby George.
Thanks for that interesting presentation, Chris. As you can see, Abby has joined us, and welcome, Abby.
Thank you.
Now we're going to turn to you, the Gen 3 community, to see what you'd like to know more about. If you haven't already, please submit your questions by clicking on the Q&A button somewhere near the bottom of your screen there. I'll turn to our first question. Someone has asked, where can I find examples of a Gen 3 data model? Chris, would you like to take that question?
Sure. As I mentioned before, if you go to gen3.org, we have user guides, developer guides, and operator guides. There you'll find some examples of some potential Gen 3 data dictionaries.
Wonderful. Thank you for that. The next person starts off saying that they prefer RStudio for their notebooks. Is that going to be an option for Gen 3 data commons either now or in the future? Abby, would you like to talk to that?
Sure. Yeah, so right now we've been demoing a lot of things with Jupyter notebooks, but we have recently put RStudio into our commons as an option for Workspace as well. And Chris mentioned that in the future we are going to have some kind of Workspace, workflow execution service so that you can launch more detailed and higher compute pipelines from our software. So that's coming soon.
Great, thanks for that. I know I personally am excited about that workflow execution system. The next person wants to clarify. Chris, it sounds like you had said that persistent files will remain after the workspace is deleted. Can you clarify that for us?
Sure. So when you spin up a workspace VM, it mounts your personal drive to that VM. And then when you terminate your VM, it unmounts that drive, but the drive persists in S3, I believe. So your personal files, as long as they're in that PD directory or some subdirectory of that one, will remain available to you at a future date.
Wonderful. Thank you for that, and thank you for that question. Somebody also asked if you plan to support any other sort of apps for computation, perhaps like Galaxy. Abby, would you like to speak to that?
Sure. Yeah, so I already talked about RStudio and our plans for the workflow execution service. We are also investigating other types of workspaces and notebooks that we can incorporate into Gen 3 in the future. So yeah, if there's one that you like, we are also taking suggestions, but Galaxy is an option that we could support in the future, yes.
Wonderful. Thank you, Abby. Somebody wonders if we have any suggestions on metadata management and documentation tools and frameworks. Chris, I'll turn to you for that first, or maybe we can hand that off to Abby. I'll let you decide.
Yeah, so feel free to peruse the user documentation. Again, there is a lot of information there. Right, so at gen3.org, if you click on the resources tab, you will find a pretty thorough user guide that has different best practices for managing and creating metadata. And was there another portion of that question?
Yeah, they asked about any sort of documentation tools or framework. Sounds like that might have been covered by Gen3.org. I think the initial takeaway, or the big takeaway from that is we would suggest Gen 3 for your metadata management. If we didn't answer that properly, feel free to post a follow-up to that.
Yeah, and then again, if you can't find an answer to your question on gen3.org in the documentation, please join our community on Slack. You can also, without joining the community on Slack, you can ask questions, I believe, anonymously in the forum. And finally, you can also email our support desk.
And you can join that Slack by requesting to join it in any of those methods that Chris just mentioned. We do have a pretty active Slack community. It's great to see the Gen 3 team here responding to people's questions, and then even more exciting when the community responds to other people's questions because they're learning the software as well. It looks like those are all of our questions. No, I take that back. Piyush Pandey told me to scroll down. Thank you, Piyush. The next question is, how do you extend the existing Gen 3 nodes, such as project and program? If we have any custom attribute if we have any custom attributes or properties that we need to add to it, is that possible? Chris?
You certainly can add custom attributes to any node. I believe the program and project nodes do need to be in place in order to run Gen3 Data Commons as it is currently. You're more than welcome. It is open source code, so you can also modify the code to your own needs if you don't like having program and project in your data model, but you can add attributes to those nodes and, of course, add any sort of downstream nodes that you'd like.
Abby, did you have anything to add, or do you think that covered it?
I think that covered it. Chris did mention we are open source, so you can fork and change our code, but if there are use cases that you think our code doesn't cover, we also encourage people to commit back to our code so that it can improve.
Definitely. The next question is, can you share workspaces or notebooks with other users or collaborators? Chris?
So when you log into the data portal and you click Workspace, it logs in with your personal login credentials. We do not yet have a functionality in the Workspace for sharing files. We considered that, but we thought there are so many file sharing applications out there already, like GitHub and Dropbox, that we would let users share files between themselves using those methods. You can, of course, have a shared login, but I think that just sharing files via, for example, GitHub repos or a Dropbox is probably your best option for sharing notebooks. You can, when you're in JupyterHub, you can download your notebook as an IPython notebook format and then share that file, and then anyone who uploads that file to their workspace can run the same exact code you ran. The only difference is any files that you downloaded in your personal workspace won't be available to them. So they'll have to either re-access that data in their workspace, or you would have to also share those files in a Dropbox or on GitHub. Great.
And a good note about any shared accounts, that's probably something you only want to do with open access data. The CCLE data set is such an example, but with anything that is controlled access, you want to be sure that you are operating by the data use agreements so that you're not violating anything there. Great question. Thank you for that one. The next question here is, are there examples of public Gen3 data commons sharing data, are there examples of public Gen3 data commons sharing data from large observational studies geared toward epidemiological research? That is a fantastic question. Abby, would you like to take that one?
In terms of epidemiological research, I don't know if we have any publicly available commons, do we? Is it?
That jives with my thoughts. We do have a data commons that has some epidemiologists and epidemiological data. However, all of that is controlled access at the moment. If that community gets to the point where they're opening that up, we would love to advertise that, but for the moment, we do not have any. Thank you for that question. That was a really good one.
We do have commons that are public that have other types of data, though, so environmental data, and then also the CCLE data and canine data.
Correct. And even those that aren't open access, some are still publicly available when you are authorized. The generic data commons is up there, and then the data commons framework services, which is powered by Gen3. All right, I don't see any other questions, so I want to thank you, the Gen3 community. Once the webinar ends, you will receive a prompt to complete a survey. One more question came up, and we do have some time. I will say still that you will receive that prompt to complete a survey. We appreciate your feedback and ideas in order to deliver the quality content that you deserve. So please fill that out for us. Looks like we have nice questions here. Wonderful. It looks like the first one there seems to be about a specific error that somebody had received using a data commons. I'd love it if you could follow up with support@datacommons.io so we can get you the proper help that you deserve on that. Somebody is also asking about, is there a way to automate the mapping process? I'm assuming they are talking about a source to target mapping from their original data to the structured data in Gen3. Chris, I think you've done this a lot. Do you want to speak to that?
We don't have any fully automated data mapping services at this point, just because most of our data commons use a different data model. We do ingest data from quite a large number of data contributors who all format their data in different ways, which makes creating scripts to import, to map data to the model sort of one-offs. One thing we have done, though, is to request data from sponsors in a particular format, and then we will write a custom script to automate mapping of that data. That is possible. So if you are an operator and you have the ability to enforce a certain standard of way of receiving data, then that can be automated, but we don't, the Gen3 team doesn't offer that service at this time.
Thanks. The next question is about, the next couple are about TSV templates for submitting data. The first one asked about finding any available templates. They did not see them on the Gen3 site, and I think that would be correct because these are, the data models are generally pretty customized, so the templates would be specific to that Gen3 commons, and we can provide those if needed on a commons by commons basis. Does that sound correct?
That is correct, and also it's worth noting that if you go to the data dictionary of any data commons, that should be publicly available. And in the if you click dictionary in the top navigation bar of a data commons, you don't have to log in. You should be able to go to browse the data model. In particular, if you go to the, if you view the data model as a table, in that view, I believe you can download any template for any node.
Oh, wonderful. That's very insightful. I should not have tried to answer that question. I need to stay in my lane. A related question is, how do we get the data from the source into the TSV template? This person doesn't want to be doing a lot of copying and pasting, so is there a way to get it into the TSV format easily?
That sort of goes back to what I mentioned previously about automating the data upload and formatting process. Unfortunately, since if data contributors come from different organizations, they very likely have their data in its native format is in a different type of structure. So it would require some reformatting and probably either copying and pasting, or it would require scripts, or you could take the data tables themselves and change the header names to the property names, for example. But we could, of course, if you email the support desk, we're happy to work with you and making suggestions if you have particular use cases.
Great. Someone is asking about the query tool that you showed us, which was really neat to look at. And they're wondering how much coding is required to use that. Do you think that's for a more sophisticated coder, or somebody with less skills could do that?
The query page, the great thing about the graphical interface that I showed first is that it does have autocomplete and full documentation of the GraphiQL schema. So if you're, for example, wondering what properties you can query or what nodes you can query, what kind of arguments you can use, you can click on Docs in that graphical window, and that will pull up the documentation. You can also begin typing, and it will give you suggestions with the autocomplete functionality. So it makes building those queries easier. With that said, it is a query more or less a query language, a GraphiQL, and there is a bit of a learning curve. So I would say that it is probably for more advanced users, but if if you have done any sort of command line programming in the past, if you've worked in a terminal, for example, I think it would be pretty easy to get up and running fairly quickly.
Great. For someone like me who doesn't have a lot of coding skills, is there an alternative?
Yes.
Great. Tell me more about that, Abby.
Yeah, so the query page, like Chris described, you type in your queries using this query language, and we have our Explorer page, which Chris demoed, and the goal of that Explorer page is to put a user interface on top of those queries. So if you are not as comfortable with queries or command line type stuff, then you can instead click checkboxes, and that will send those queries for you. So overall goal is just to provide an experience for people that aren't as comfortable using programming languages.
Wonderful. And if you are operating your own Gen3 Commons, you can customize those little checkboxes or bars to help you build a virtual cohort of interest, and little customizable graphs or charts that will pop up about that. And if it's a commons that we're operating, you can work with us and we can customize those for use cases. So the next question is about downloading a file using the object ID. This user is wondering how the end user finds the object ID for a common that might not be their commons. I'm not sure who wants to take that one.
Probably Chris, but I can also contribute.
Okay. How would the end user find the object ID for a comment that's not theirs? Well, I think you would have to have access to the data commons for which the GUID was minted in order to find the GUID. I believe. Yeah. I don't think there's any other way to access files if you don't have access to the data commons, if I'm understanding the question correctly. If I misunderstood that question, you can repost it.
That's how I understand it as well. For downloading files using object IDs, those object IDs are what we call GUIDs, the Global Unique Identifiers. And typically those have some kind of access control associated with them, so you would need to have access to that in order to download it.
Great. Our next question here is about resources, either code or people, who are involved in any sort of integration with some of our collaborators. This person is specifically asking about our collaboration with Seven Bridges Genomics. I think I can start off by saying that I think emailing us would be a great way to find those resources. All of our code is open sourced, and on our GitHub page that is linked on all of our websites and the slide deck that we will be sending out. And you're welcome to ask us, once you're invited to our Slack channel, more about those collaborations. We do have a lot of collaborations that we're very proud of and would love to talk more about those. Chris or Abby, do you have anything to add?
I think that email or Slack is a good way to get involved from this perspective. Yeah.
Great. That again looks like all of our questions. So thank you, Gen3 community. We welcome and look forward to hearing from you. If you have any remaining questions about today's webinar or any that we misunderstood or I accidentally skipped over, please feel free to follow up with us. And those questions can be about the webinar, our software, the UChicago Center for Translational Data Science, and also feel free to start putting in pull requests to our Gen3 GitHub repos. We will share a recording of Chris's presentation on YouTube, and be sure to watch for news about our next webinar upcoming. Thank you for participating, Gen3 community. We look forward to engaging with you more soon, and this concludes today's webinar.